We have some given information that AB is congruent to DC and AF is congruent to DE and angle A is congruent to D. Those are all marked on the diagram. So the first thing we need to do is just put them into our proof. We go ahead and say AB is congruent to DC. F is congruent to DE. Angle A is congruent to angle D. And the reason for that is given. Let's go back up to our picture. And we want to prove that triangle BFE, which is this triangle right here, is congruent to triangle CEF, which is this triangle right here. So that's our end goal. So I just wanted to highlight that so we know where we're heading. Looking at this information, we can state that this triangle is congruent to this triangle by side angle side. So that's our next piece. Using the given information, we can draw another conclusion. So we're going to say that triangle DCE is congruent to triangle ABF. And our reason is the side angle side congruency theorem. From that information, we can now draw the conclusion that this line and this line are congruent because they're corresponding parts of congruent triangles. So let's say that BF is congruent to CE, and that is corresponding parts of congruent triangles are congruent, CPCTC. The next thing that we know is that FE is congruent to EF. And that is the reflexive property. So we're going to look at this and we're going to state that triangle ABE, so we're looking at this triangle right here, is going to be congruent to this triangle right here because of side, angle, and side angle, side. So I'm going to erase that. There we go. So we're going to come say that triangle ABE is congruent to triangle DCF, and that is by side angle side congruency theorem. Now that we know that those two pieces are congruent, we can look at BE. So this line right here is going to be congruent to this line right here. think we're on 4 marks this time. 1, 2, 3, 4, and 1, 2, 3, 4. And that is because of CPCTC. So BE is congruent to CF by CPCTC. Congruent or corresponding parts of congruent triangles are congruent. And then we have enough information to prove that triangle BFE is congruent to triangle CEF, and that is a side-side-side congruency theorem. This is the side angle side congruency theorem, and that was what we were trying to find. Go ahead and pause your video and do the try it, and come back and check your answer. There was a lot of given information. Although that they didn't write out a given section, they put a lot of markings on the triangle. And so that information is given to us with markings. So I have listed that all here for you. Based on that, we now can look at this angle and this angle being congruent, which makes STX an isosceles triangle, which means that we can, well, we need to actually state that. So triangle STX is isosceles. And that is base angles theorem. Base angles of isosceles triangle theorem. THM is abbreviation for theorem. And because of that, we know that SX is congruent to XT. And that is the definition of isosceles triangle. So coming up here, this is what we determined right here, and there are congruent. We also have a pair of vertical angles right here and right here. So angle SXW is congruent to angle TXV because of vertical angles. And then we can state that triangle SWX is congruent to triangle TVX. And let's look at that. So we have angle, angle, side, and angle, angle, side. So that is by the angle, angle, side congruency theorem. And from there, we can conclude that SW is congruent to TV because of CPCTC. So SW is congruent to TV. That's what we just said. And now we can look at these outside triangles. We have, this is what we're trying to prove, this triangle and this triangle. And we see that they are right triangles, and we have a hypotenuse and a leg. So we can go ahead and make the conclusion that triangle SRW is congruent to triangle TUV by the hypotenuse leg theorem.